Hi, my name is Angelica, and today I'm going to introduce you to FlexLogger. FlexLogger is configuration-based data logging software used to log synchronized mixed measurements. Today we're going to walk through how to acquire, visualize, and log data all without programming using some compact DAC hardware. The first step that you take when you launch FlexLogger is to create a project. Projects house all of the information such as your hardware settings, UI elements, and logging configurations, so that way you can reuse those settings across multiple tests. So let's go ahead and launch a project, give it a name. Now FlexLogger automatically detects the hardware that I have connected to my system and loads this into a channel specifications table where we configure our measurements. Today we're going to configure 4 measurements: an analog sensor for vibration, a counter input for a tachometer reading, a custom physical measurement from a light sensor, as well as reading some CAN signals, some simulated CAN signals. FlexLogger contains sensor-specific configurations that match the exact physical measurement and sensor that you're using. So for our vibration sensor, I'm going to give our channel a descriptive name for my accelerometer in the X direction. And I'm going to select acceleration as my physical measurement and an IEP sensor as my sensor class. My accelerometer has a dynamic sensitivity of 175 millivolts per G, so I'm going to set that now. All of these settings, including the physical and electrical properties, as well as the scaling information, all get saved to files so that way I have context around how my measurement was configured. I'm also going to copy and paste this setting for my accelerometer in the Y direction. This makes it easy to set up multiple channels and ensures that I don't make any mistakes after manually configuring my sensors. The last thing that I'm going to do is configure my sample rates. I can configure a mix of different sample rates that are all synchronized because of the different timing engines in the compact DAC chassis. I'm going to change my sample rate to 25 kilohertz. The next thing that we're going to do is configure our RPM measurement using our counter. This uses the angular velocity physical measurement for a frequency counter. I'm going to change my minimum and maximum to represent what I expect for this sensor. This tachometer emits 2 pulses per revolution, so I'll enter that into my scaling information. And I can use the live data preview to confirm that I'm getting the data that I expect. So running at about max, I can see that I'm coming in around 4,000 RPM, which makes sense. Next, we're going to configure a custom physical measurement. So if I'm using a non-standard sensor type, I can create the measurement and use physical units that make the most sense. For our light sensor, we're going to configure a custom physical measurement using voltage. And I'm going to use lumens as my units. For the purposes of this demo, we're going to do an approximate linear scaling. The last thing that we're going to configure is our CAN measurements. The first thing that I need to do is to configure my interface settings. And so because I'm doing a loopback test, I'm going to enable the internal termination resistance. And then I'm going to add the actual database and signals. I'm going to select my example database and choose the signals that I want to add in this case, waveforms. Now that we've configured our measurements, we're going to configure our logging specifications. I have the base path where my file is going to be saved, and I'm going to give this a more descriptive log name. I can also include some custom information to be stored in my file. For the demo today, I'm also going to choose to segment into multiple files based on a certain period of time. In reality, this is something that you would likely use for long-term tests, but today we're going to choose to create a new file every 60 seconds. This is something that can help manage the file size on disk, as well as periodically save files in the case of an unexpected event or a system failure. Let's go ahead and start logging. So now we're going to visualize our data. FlexLogger contains a variety of drag and drop engineering indicators that you can use to visualize your data. So I'm going to drop a graph to display our vibration and RPM measurements. And so you can see that when I added these two different measurement types, it added two different axes to show the different scaling for these different measurements. I'm also going to add a graph for my CAN signals. I'm also going to add a gauge for my light sensor. The last thing that I'm going to add is a Boolean for alarming capabilities for my light sensor. I can customize my screen in a variety of different ways. I can choose to add upper and lower ranges to any of my measurements to show potential limits or thresholds that are being exceeded. So if I increase my vibration measurements, I can see how the amplitude starts to increase with the increase in fan speed. And if I tap, I can see the increase in the acceleration data. I can also use the different chart interactive controls to zoom in and get more information about my signals. Let's configure the alarming capability for our Boolean. This is measuring the amount of lumens being detected by my light sensor. I'm going to change the behavior of my LED to be true when it's outside certain bounds. So that way, when my lumens exceeds the value of 5, the Boolean LED will turn on. So now I'm going to shine a flashlight on my light sensor. And so we can see that that alerts us that we've exceeded a threshold. Now that I've configured my screen, I'm ready to stop my recording. You'll notice that we've been logging multiple different files that have been recording or segmenting approximately every 60 seconds. After I stop recording, I can review my data in the integrated data viewer. I can use this to validate that I've captured all of the information that I need. I can change the scaling to see how when I increased the RPM or the fan speed, we saw the increase in the vibration data. I can also add different measurement types to my graphs as well, such as the CAN signals that I acquired. We can also review the custom properties that include the hardware settings, as well as the scaling information for our sensors to know exactly how our system was set up. Once I'm finished, I can choose to save my data and export it into a variety of common file formats, such as Excel. Today, you've seen a basic introduction of how you can use FlexLogger to acquire, visualize, and log your data. For more information, visit ni.com/FlexLogger.